Scaled Figures Level 2. The figure on the right is a scaled copy of the figure on the left, though it might have been rotated. And obviously you can see it's rotating. They're kind of showing the application. So first of all, just kind of a recap what we did in video 1 or in the level 1 figure. Pre-image is on the left, image is on the right. Pre comes first, image comes second. So let's go ahead. You don't have to draw this. I'm just going to go ahead and copy the whole diagram. I'm just going to put that into my whiteboard here. And the first question is, what side on the figure corresponds to segment PR? You don't have to do this, but I think this is going to be just make sure it's super clear. So what I did is I copied the image, and what I'm going to do is I'm just going to resize this so it's the same size as the pre-image. That's the one we're starting with. So not totally perfect. And then what I'm going to do is I'm just going to go ahead and I'm going to take this figure over here and I'm just going to rotate it so it kind of sits within there. So obviously the pre-image was enlarged. The side in question that they're asking us was PR, and P to R is this one here. And remember, corresponding means same relative position. So from P to R would be P to U. That's what we're looking. So let's, or sorry, W to U. So there's W to U. And I am now going to go ahead and show our calculations. Again, the instructions from Google Classroom, write down the scale factor equation. The scale factor equation says find the length of one of the sides of the pre-image, and we'll multiply that by the scale factor. And what happens is when we're done multiplying one length of the pre-image times the scale factor, that'll give us the actual length of the corresponding side on the image. Now the problem, as you can clearly see here, is that if I use P to R, this is a diagonal. Now I still could find the length of the diagonal by turning in this into, using the Pythagorean theorem again, turning that into a triangle, but it's more work than we need. So the advice that I give you in the first set of the videos is to simply go ahead and find a side that has a horizontal or vertical line. So to be real clear, I could go ahead and find the scale factor with those two sides because those are vertical, or I could use technically these two sides, those are also vertical. Let's go ahead and use the green one though. These sides look a little bit easier to deal with. So from P to Q, that has a length of 2, and then from W to X, it looks like it's 1, 2, 3, 4, 5, 6. So the pre-image is 2 multiplied by K is equal to 6, which it simplifies to 2K is equal to 6, and then division property of equality, and we find out K is equal to 6 over 2, which reduces to 3 over 1. Remember, divide by 2, or it can simplify just to the whole number 3. So remember video 1, it talked about that if the scale factor is larger than 1, it's considered an enlargement. Obviously, the pre-image enlarged a significant amount to turn it into the image. So the scale factor in this case is going to be 3. Check to make sure we got it right. Okay, cool. Let's go ahead and find a reduction. So I copied the figure and I put it in the whiteboard. Again, you don't have to do this. I'm just going to go ahead and show you that. Let's see, I want to have this figure kind of, to me it looks like about that right there. So it kind of fits inside, or you could leave it above, whatever the case. I'm just going to kind of draw this right here just to make sure I don't mess up the corresponding sides. So the first question that they asked is they said I to G. So I to G is this one right here. Cool, I'm just going to put it on the outside. And that would correspond, let's see, from I to G would be from L to K. So let's go ahead and look for L to K, or K to L, however you want to look at it. And now we'll have to come up with our scale factor equation. And the scale factor equation, again, we want to go ahead and find the length of one side of the pre-image, multiply that by the scale factor, and we should find the corresponding length of the side in the image. Again, I'm not going to use these two side lengths. Those are diagonals. It takes too much work. So it looks like the only thing the only side that actually would be really quick would be this one right here and this one right here, because those two sides are horizontal and it's super easy. So let me switch over to blue. It looks like we're going to go to J, from H to J. So H to J, it would have a length of 1, 2, 3, 4, 5. We're going to make sure that that lines up though. Yeah, there we go. That looks a little bit better. All right, H to J, sorry. 1, 2, 3, 4, 5, 6. That has a length of 6. Sorry about that. Where's my marker? So that's 6. And then from N to M, this would be 1, 2, 3. So the length of that is 3. So the preimage is 6 multiplied by K, which is the scaled factor, is equal to 3. So we'd have 6K is equal to 3. Divide by 6 on each side, and I find out that K is equal to 3 over 6, which reduces to, let's see, divide by 3 over 3, reduces to 1/2, and that's going to be our final answer. So K is equal to 1/2. And we're good to go.